Good morning, third grade. How are you guys doing today? So we're on lesson 106. Lesson 106, and that's page 564. So lesson 106, that's page 564. And today we're going to be talking about estimating area. And this is going to be part number 1, because part 2 will be coming a little bit later. So estimating area. And today we're going to new concept. So page 565 on our new concept. So we're going to read this together, okay? We're going to be using our math books a lot, and I'm going to be using my math book a lot, and I'm not really going to be using the chalkboard today just because there's a lot of like visuals in the book and the examples that I want you to see, okay? So let's go ahead to new concept, and if you can follow along with me, please. Here we go. A grid of squares can help us estimate the area of a shape. Below, we show a figure on a centimeter grid. Each square on the grid is 1 square centimeter. We can count squares to find the area of the figure. So, let's see here. So, if you see this, okay, in your math book here, this is the grid, right? And this is the picture they drew. And each one is 1 square centimeter, okay? So we have 1, 2, 3, 4, 5, 6, 7, 8. And these two are halves. So the halves actually become 1, okay? Because if you put the other half here, it fits, and then that will become 9. So let's keep reading, though, in your math book, okay? So underneath that picture, it says we count 8 whole squares and 2 half squares in the figure. So the 2 half squares equal 1 whole square, which is what we just said, right? So the area of the figure is 9 square centimeters. So that picture there, right? This whole picture is 9 square centimeters total, okay? So, when shapes are more complicated than rectangles and squares, we often estimate the area by counting the squares on a grid, just like that, and that is the grid, right? And so, what polygons have areas that cannot be found by multiplying the length times the width? You guys know? Maybe some quadrilaterals, right? Some triangles, some pentagons, hexagons, and octagons. Okay, those are the polygons that have areas that cannot be found by multiplying the length times the width. Okay, let's see here. Okay, let's go to our example number 1 here, okay? Example 1. So again, please, let's read this together. In this diagram, each square equals 1 square foot, okay? What is the area of the figure on the grid? Now, it's very important for you guys to know and to remember this. Let me get my math book close up here. Okay, so if you see here, this equals, one of these equals 1 square foot, okay? So one of those full like boxes there equals 1 square foot. So what we're gonna do is we're gonna count, okay? So let's count. We count, so let's count the whole squares, okay? So I'm gonna count while you count. Let's see. Okay, I counted. Did you find your answer? How many whole squares are there? That's right, there are 10. Maybe if I can show you up close. So the full squares will be 1, 2, 3, 4, 5, 6, 7, 8, 9. There was one more. I know I did count 10 though, but it's kind of hard looking at the camera and doing this. Now, we have the 10 whole squares, and then so we add, oh, and then how many half squares though? How many half squares? So look at your book really quick and count the half squares. So the ones that are like in half, okay? That like the half squares. Okay, I counted my half squares. Let's see here. Okay, so we have, that half square, that one, 2, 3, and 4. So 1, 2, 3, and 4. Those are the half squares, right? So if we have 10 whole squares and then 4 half squares, the half squares, so if we have the 4 half squares, right? So those can be equal to what? So the half squares can be equal to how many whole squares? That's right, 2. So 4 half squares are equal to 2 whole squares, because this can be a half, like these two, a half and a half as a whole, a half and a half as a whole, right? So we have the 4 half squares equals 2 whole squares. Okay, I hope you guys are understanding that so far. So we have the half squares there, those 4, and those, so if we put that one and that one together, that'll be 1 full square. If we put that one and that one together, those 2 half squares, they will become 1 full square. So that's 2 whole squares. So we have 10 whole squares plus 2 whole squares. And how many is that? That's right, 12. So the area of that equals 12 square feet. 12 square feet. And that's how we found our answer in example 1. Was that so hard? It's pretty easy, right? So all you would have to do is just count your squares, the whole ones, and then if there are half ones, right, you would just put the half ones together to make a whole one. Pretty easy, right? Okay, good. So now what we're going to do is the shapes, right? So the shapes do not always have straight edges or fit exactly onto grids. Monica drew this shape on a piece of centimeter grid paper. So if you see this, so one of these equals 1 square centimeter, 1 full square. And if you see, how many full squares are there? So I definitely see about 3 full squares. Do you see? So I have 1 there, 2 there. I mean, I know there's a little bit not shaded, and then 3. There's actually like a little bit there too. So there's 1, 2, 3, 4. About 4, that's almost fully shaded. So let's go ahead and turn to the next page, okay? And if a square is fully or mostly shaded, we count it as 1 whole square. If a square is about half shaded, we count it as a half square, right? So, if a square is only like barely shaded, we do not count it at all, okay? So we see 5 squares that are whole or almost whole and 4 squares that are about half shaded. So let's see the area of Monica's shape. Let's go back to Monica's shape here. And so, whoops, trying to get close to the camera here. And so we have 1, 2, 3, 4. That's about fully shaded. These 3 and then that one. That one's about half, half, half. And that, I think that one's about half. So those ones like barely count, okay? So half, 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 and that's about half, right? Okay, so let's go back to the other page. I just wanted to show you guys that really quick. Okay, so we see again that we see the 5 squares that are whole or almost whole and 4 squares that are about half shaded. So then it would be equal to 7 square centimeters, okay? We're gonna do another example, example 2, to see a little bit more on this, okay? So let's read the example 2 together, okay? In this diagram, each square equals 1 square meter. You're gonna estimate or like round or whatever's closest to the area of the surface of the pond. Now, to estimate the area, kids, we have to count each nearly whole square in the figure as a whole, as a whole square. So, one full of those, sorry, yeah, one full of those equals 1 square meter. Okay, so it's going to be hard to count this on the camera, but you can count it in your math book right now. So we're going to count each. So remember, we count each nearly whole square in the figure as a whole square. So if it's mostly shaded, like if it's mostly blue in there shaded, then it's one whole square. Okay. If it's only like halfway shaded, then it's a half square. If it's only like a little bit shaded in the square, then it doesn't count. Okay, so let's count. We're gonna count together. So we're gonna count the little squares now. Okay, so I'm gonna give you a few seconds while I'm doing it in my book. You'll count in your book. Ready? Go. Let's count. Okay, how many whole squares did you count? Yes, I counted 24 whole squares. Very good. And how many half squares? Very good. So there are 6 half squares, right? So we have 24 whole squares and 6 half squares together. Okay? So the 6 half squares we know are what? That could be equal to 3 whole squares, right? So now we know that it's 24 whole squares plus the 3 whole squares equals, what's 24 plus 3? 27 whole squares, that's right. So our answer is 27 square meters because this equals to square meters, right? Okay, so that was pretty easy, right? So again, if it's most of it shaded or all of it is shaded, that's 1 square. If it's only halfway shaded in the blue, like only halfway, that's a half, like a half square. Remember, 2 halves equal 1 whole. 2 halves equal 1 whole, okay? So again, all it is just looking at the picture like really closely. If it's most of it shaded, you know it's 1, count as 1. If it's all of it shaded, we know it's 1. If it's only halfway shaded, we know it's half. If it's like only a little bit shaded in there, we know that it's doesn't count. Okay? So, we see here, I think you have lesson practice A and B here. And so make sure you do that. And then that is really good practice. So I'm trying to think if I want to do these with you. Let's go, we can do B together, okay? So look at B, it says estimate the area of this figure. So first of all, how many full squares do you see? So we're on page 567, okay? So let's count. We're counting the full squares, or mostly shaded squares. Okay, how many did you count? I counted 11. Very good. 11. Let's see how many halves. Ready? Count the halves now. Like the halfway shaded. Okay, I counted 6. Okay, I counted 6. Hopefully you counted the same. So 6 halves equal how many holes? Good, 3 holes. So 11 holes plus 3 whole squares equals 14. So our answer, remember, this is equal to 1 square yard, so our answer would be 14 square yards. Okay, I wanted to do that one with you just for an extra additional practice. And I hope you guys have a good day. Try your best in your written practice and keep practicing your multiplication and division facts and your long division at home. If you do have any questions, let me know. And hope to see you guys soon. Miss you guys. Bye-bye.